All right, today we're diving into something truly radical. It's a new theory that tries to completely rethink our ideas about matter, gravity, and even what empty space really is. And it all starts with one simple but pretty provocative question. I mean, really think about that for a second. What if the empty space all around us isn't empty at all? What if it's actually a dynamic, vibrant substance? What if the vacuum itself is the fundamental building block of literally everything we see? So, this theory proposes that all of space is filled with just one thing, a primal field. You can think of it as the ultimate bedrock of reality. Now, it's described mathematically by this single complex equation. And I know, equations can look a little scary, but stick with me. We're going to break down its two key parts, and it's actually pretty intuitive. So, this one field has kind of two faces to it. The first is its amplitude, rho. You can think of that as its energy density, like the actual depth of water in a pond. The second part is its phase, theta, which is more like the pattern of ripples on that water's surface. So you've got the depth and you've got the ripples. They are two sides of the very same cosmic coin. Okay, so if the entire universe is just this underlying field, then a huge question pops up right away. What are we? What is a planet, a star, or a person actually made of? And this is where we get the theory's first, huge claim. Matter isn't some separate, fundamental thing. It's simply a stable, localized knot of excess energy within the vacuum's amplitude. So in this view, you're not a collection of particles floating in a void. You are a persistent, incredibly complex ripple in the very fabric of the vacuum. Wild, right? Okay, fine. So matter is an energy knot in the amplitude. But how does that knot create the force we all know as gravity? How does it tell other things to fall towards it? The answer they propose is, well, it's stunningly direct. This simple little interaction term here shows that wherever you have a knot of matter, that's our rho b, it directly influences, or biases, the vacuum's phase, that's our theta. This means the two phases of the vacuum, its energy and its orientation, are just intrinsically linked. So this builds a completely new chain of causality for gravity. Check it out. Step 1, an energy knot, which we call matter, forms in the field's amplitude. Step 2, that knot automatically creates a distortion in the field's phase all around it. And step 3, we perceive and measure that phase distortion as the force of gravity. It's not matter bending space-time, it's the amplitude of the vacuum bending its own phase. This leads us to a brand new definition for gravity itself. The gravitational field, G, is nothing more than the gradient, or you could say the steepness, of the vacuum's phase. So the faster the phase changes from one point to the next, the stronger the pull of gravity you feel. It's all about the slope. So we have these really powerful new concepts, but, can we turn them into a concrete, testable law of physics, something that can make predictions about the real world? To do that, physicists use this powerful and really fundamental tool called the principle of least action. Now, the details are pretty complex, but you can just think of it as a kind of universal engine that takes the basic properties of a system and automatically derives the exact mathematical law that governs its behavior. Now, the core assumption that makes this theory so unique is how it views the vacuum's response. See, standard physics often treats the vacuum like a perfectly stiff spring. Its response is linear and predictable. But this theory suggests the vacuum's response is nonlinear. It's more like a really strange spring that gets surprisingly weak, but only when you pull on it a tiny, tiny bit. This strange, nonlinear behavior is captured by a special mathematical tool called the vacuum response function, known as mu. Think of mu as a dial that describes the vacuum's stiffness, and that stiffness actually changes depending on the local strength of gravity. So when you feed all of these ingredients, the primal field, the matter knots, and that non-linear response function, into the engine of least action, this is what comes out. We get a new modified law for gravity. It looks a bit like the old law, but with that crucial mu function, the vacuum's response, tucked right inside. And that changes everything. An equation is one thing, but the real test is what it means for the universe. Does it make predictions that we can actually go out and check against what we observe? And this is where the power of that mu function really comes into play. In high-gravity environments, like our solar system, mu is basically equal to 1. The equation simplifies and becomes identical to Newton's law, which we know works perfectly here. But in very low-gravity environments, like the outer edges of galaxies, mu behaves differently, and the law predicts a whole new kind of gravitational behavior. And here is the crucial prediction for that weak field regime. The theory states that gravity doesn't fall off as quickly as Newton thought it would. Instead, the actual gravitational force squared becomes proportional to the weaker Newtonian gravity we'd normally expect to find there. Now, this isn't just some abstract equation. When you apply this new rule to rotating galaxies, it directly predicts a famous astronomical observation, the baryonic Tully-Fisher relation. For decades, astronomers have seen that a galaxy's rotation speed is tied to its visible mass in this exact way, but they never really knew why. This theory appears to derive that relationship from first principles. The ultimate payoff here is a universe that might not need dark matter. When we observe galaxies, they spin much faster than Newton's laws predict based on the visible matter alone. The standard solution is to invent a massive halo of invisible dark matter. But the prediction from this new vacuum theory, shown here in the third bar, matches the observed rotation perfectly, with no need for dark matter at all. So let's just pull all of this together into the new worldview we've just explored. Matter is just stored energy in the vacuum. Gravity is the phase's response to that energy. The laws of gravity aren't fundamental. They're just emergent properties of this deeper field. And most strikingly, the vacuum's own nonlinear behavior appears to explain the mystery of galaxy rotation. And that leaves us with one final, mind-bending question. If this picture is right, and both matter and gravity are just different emergent behaviors of a single underlying reality, what other secrets of the universe might just be hiding in the vacuum?